Hello everyone, in this exercise of SolidWorks, we will create a spur gear assembly and later on we will create animation for this and also calculate the center distance between these two spur gears. Let us start. File, new, assembly. We will go in assembly and OK. This window comes, cancel it, cancel this assembly. And background select plain white and unit system I am taking millimeter gram second. Okay, this in graphic area we will bring the spur gears. How? This is the task pane. Task pane there is a design library. In design library you will see there is a toolbox. If the toolbox, you don't have the toolbox, you can bring from here option add-ins, and this is the toolbox library. Check it and OK it. Then they will come in this. Okay, but I have the toolbox here. Expand it, and this is the expand. And you first select the unit system. You will select the unit system. That is the ISO. In ISO, you will get the power transmission. This one, double click, and then you get gears. This one, there are different types of the gears you will find here. I will take spur gears here. Click and drag it. Okay, and drop in the graphic area. Okay, now you decide the dimensions for this gear. I am taking the module for this gear is 5. Number of teeth I am taking 40. Pressure angle 20. Face width I am taking this one. Face width I am taking 30. Hub type is A, and nominal shaft dia this one I am taking 50. Key is this one, that is the rectangular key, and show teeth. So teeth is the 40. I am hit the right button. Now one more gear is coming. I want one more gear. Okay, and click it. And one more gear is coming, but I don't want, and cancel it. Okay, right, this one. In second gear, I want to change the dimensions for this size. Right click on this one, edit toolbox component. Okay, and then you go and assign the dimension parameters for this gear. I am taking module same. Number of teeth I will take 20 mm only. This one I am taking 20 mm teeth for this gear. Pressure angle will be same. Pressure angle is standard, that is a 20 mm, 20 degree. Face width 30. Hub type this one, but shaft die I will change, and that I will change. This I will keep the 35 mm first. Okay, and this one. First part in the assembly, if we import, that it remains the fixed, but I want to keep it float. Right click on this part, first gear, and it keep it float. Now it will moving. This one, this will moving. Now first we will select in the reference. This is the reference geometry. I am selecting the axis. I will select the option two planes. I will take this option I will select and take the two planes, front plane and top plane. You will get a axis, this one. Okay, now mat. In the mat, axis is automatically selected, and select this board, and make the relation concentric. Okay, this one, cancel it. Now another mat, select right plane and select this face, big one, this one, and make the relation coincidence, this one. Okay, now again select this face of first gear and second face, this one, and make the relation coincident. Okay, this one, cancel it. Right. Now I will make a center distance between this and two. How I will calculate? This is calculator I am taking. Center distance, first we will calculate the PCD of this one, first gear. How PCD will calculate? PCD for the first gear, 5 mm is the module into number of teeth. Number of teeth for this gear is 40. So this is the PCD of first circle, first gear, but divided by 2, half, that is the 100. This is the half of the PCD, 100 mm distance for. Cancel it. Same way for we will calculate this one. Cancel. 5 mm module for this one, second gear, into 20 is a 3. This one 100 mm. Half of this thing, that is equal to 50. 50 plus 100. This will be the 150. 150 will be the center distance of this bore dia, center from center to center. So this, in this way we calculate the center distance. Now how will we use? First, on the right plane, because right plane is coincident with this face, right plane sketch, I am drawing a line, central line here, horizontal line I am drawing. Okay, this is the horizontal line. I have calculated the center distance from the center of this bore to the center of this bore. I have calculated 150. I am assigning the dimension 150. Okay, this one. This is the dimension. Okay, now out of the sketch, now mat. Now select this point, and this bore, and make concentric relation, this one and this one. Cancel it. Now this one. Make the adjustment in the move component, and the command manager you assembly. This is move component. Okay, this is a collision detection here. This one, collision, all components, and highlight faces and sound. This is the advanced option. You will select this one. Suppose I move at this time. This will you will see now it is colliding for this. I am taking this position. Okay, this one. Now in the mat I am making a gear relation in the mechanical gear relation, and this is the gear relation. Okay, for gear relation I am selecting this bore and this bore. Okay, this bore and this bore. You will see the message are flashing here. This showing the shaft dia of first gear is 50, but I am taking here, double click on this, I am taking the number of teeth, enter this one. Okay, now in the same way on this message where the 35, this show the bore dia of this second gear, I am double click on this one and give the number of teeth 20 mm. Okay, this one. Same will appear in this side, left window. Okay, now I am hitting the right button, this one, and cancel it, this one. Now you will see this is moving. One is clockwise and another is anti-clockwise. Okay, in this way. Now I give the color for this thing. I am giving this color for, and this one. This is the color for this one, and color for this one. Second gear is the, I am giving the yellow color, this one, light color, this one. Okay, this is the. Now you can rotate it. This one, this is rotating here. Hide the sketch, this one, hide the sketch, and this one. Now we will give the animation for this thing. how right click in the command manager and toolbar, there is a motion manager here. Okay, you will see there a motion study at the bottom. Click and this appears. First you give the for how much time you want to give the animation. I suppose I want to give for 12 seconds. And second, motor direction, rotatory motor, component direction, I am taking this one. This is clockwise, but this will move anti-clockwise, because this is clockwise, this is anti-clockwise. I will change the direction from here, left hand side, this one, okay. And RPM I am taking, as per requirement, I am taking 10 RPM, okay, and hit the right button. Now there is this one, this gear type item. This is the motion steady properties. Click here and you set the frame per second. I am taking 50 frame. This is for the smooth operation of the animation, hitting the right button, okay. And this one, now you calculate it, this one. In this way you provide the animation and calculate and play it, this one. Okay, in this way we can assembly how to import the gears from the design library, toolbox, sorry, and how to calculate the center distance between the gears, and how to provide the animation for the spur gears. I hope you would have enjoyed in this exercise. You please like, share, and you please subscribe this channel. Thank you for watching. Thank you very much.